I will discuss two important topics. As per your actual syllabus, today we are supposed to discuss fetal hemoglobin estimation. Okay, we will just alter the concentration, acid concentration of N/10 HCl. Okay, then we can go with the same N/10 HCl method with a different acidity. We can detect fetal hemoglobin. Okay, so where does the fetal hemoglobin present? Fetus. In the fetus. Okay, in the just born babies, neonates. We can see this. So that is all about fetal. Then coming back to ABO grouping. So let me discuss what is ABO grouping. You already know everything, but still, yeah, 1 second. One small thing. Yeah. Pay attention. Yeah. ABO grouping. So, who discovered ABO grouping? Carl Landsteiner. Yeah. Anyway. Then keep in mind, ABO grouping is different from. Okay, ABO grouping is different from blood typing. Grouping is different from typing. Okay, what is blood typing means? Okay, there are not typing. Okay, classically blood has been divided into two types, either a positive type or negative type. Okay, yes. Okay.
The pause.
Okay, fine. Listen. I will tell a simple story. Okay, history. What Carl Landsteiner did is, before Carl Landsteiner, the blood transfusion is very randomized. I will take pig blood, I will transfuse, because we thought that all animals have blood and all blood is in red color. We thought all blood is same. Okay? All animals, every blood is same because we all have same colored blood. So by this idea, they started giving various animals blood to the humans after surgery, but they are dying. So the post-transfusion death is very high during initial days. Okay. So what our Carl Landsteiner did is, he started taking the death rate. He started going to the hospitals. He took the data. Okay, you given both blood to this patient and he died. Then he saw the registry. He has some 10,000 transfusion data. Then what he understood is, there are success rates also. Some patients are alive when they have exchanged their blood. Okay, and he came to know it is human to human blood transfusion where the success rate is high. So we came to know we need not to depend on animals, better go with humans. Then in the humans category, not all are alive, some people are dying, and he took the people who were successfully transplanted. The people from human to human who are alive after transfusion. Okay, he got a small number of group. From 10,000, he got some 500 successful patients. Then what he did, he collected their blood samples, 500 patients, successful blood samples. Okay, the one who had a successful stories, he took their blood and he started checking what is the interesting things in this blood. Then he understood, by this era, okay, by the time of Carl Landsteiner studies, already we understood the concept of immunology. Already Robert Koch contributions, Louis Pasteur contributions, Ulrich Paul contributions, they already did good studies in immunology. They understood that there is something in the body that is producing antibodies towards a specific thing. So with this ground knowledge, Carl Landsteiner started isolating various types of antibodies and antigens. Then surprisingly he understood the blood grouping is the simplest thing. It's not as complicated as bacteria or microbiology. Okay? The blood has a very simple rules. The rules are, blood has antigen, we understood, and antigen are only two types. Either blood has an antigen A or blood has an antigen B. That's it. Okay, this is not a single day discovery. This took almost 7 to 8 years of painstaking, experimentation. Okay, every day he was checking what marker is, what antigen is responsible for this. Are alone, fine, he's keeping such an innocent face. Where is the headmaster? Anyway, sit there. Okay. Yeah. Karl Einstein understood that blood has only two antigens, antigen A or B. Okay. So he said like this: some individuals have A antigen, hence they are blood group A. Some individuals has B antigen, they are blood group B. Then he understood some individuals have both A and B antigens. Some individuals have both A and B antigens. That is blood group AB. And some individuals don't have these antigens. Okay? So that became blood group O. This is what Karl Einstein did. He discovered blood grouping system. This is called blood grouping. Okay. Now, I will tell another statistics. Before Karl Einstein, after giving blood to the patient, the rate of death is almost 90% chances that patient will die. Only 10% chances that he or she will be alive. But after grouping, the patient death rate has been reduced drastically. Now the chances of death is only 10%. It became reverse. The chances of death after ABO grouping is only 10%. Okay. So it's a breakthrough actually in the medicine, in transfusion medicine. Right? But still, why this 10%? I will tell this here. We came to know B group individuals. I given this is a donor and receiver also B group. I given blood but they died. Why this person died even though they are same group? This is a problem of Karl Einstein. Even the same group but still there is a death rate. So his classification is so strong. This is not so appropriate. This is not correct. There are some problems with this model also. And he didn't understood this. And it took only 7 years to develop this classification, but it took almost 16 to 18 years to detect the 10% issue, to identify the solution to 10% issue. Why this is 100% accurate? Why this is not 100% accurate? Okay, he started publishing papers. Okay, very good research articles throughout the world, and one scientist from other part of the world, okay, he is working in African countries, and he understood that he is working intensively on blood transfusions. He is working on macaque monkeys, rhesus macaque monkeys. Okay, he came up with a new classification of blood. Rather than ABO classification, he said some of the monkey has some antigen, monkey anti-sera Q2, okay, and humans exhibiting some of the human blood groups are reacting with these monkey antibodies. Okay, based on this monkey antibody reaction, human blood groups are broadly categorized into either positive or negative. Whether human blood reacting with this monkey sera or whether it is not reacting with this monkey sera. And these monkeys are rhesus monkeys. Rhesus monkeys. Fortunately, in India, whatever street monkeys we are seeing, they are actually rhesus species. Okay, they are very common in tropical regions. So, that's how we got it. Sometimes luck is important, okay, to gain that whatever we need. Why I am saying this because imagine rather than rhesus monkey, there is another type of monkey near this scientist. We might not discover it. So yeah, it's in right time at right hands. We cracked this story. Okay. So immediately his findings he sent to Mr. Karl. Okay. His name is Mr. Alexander Weiner. Alexander Weiner. Okay. Alexander Weiner given his data to Mr. Karl, and they both came with a new system, ABO plus archetyping system, and that is how this became a standardized model. Now the rate of survival after transfusion became 99%. Only 1% chance of death after this, after transfusion. But still 1%, I understood 1% is still a gap, and that 1% is some rare groups. Bombay blood group, Dull, Diago, Duffy, Kidd. There are many blood group systems. There were rare blood group systems. Okay. So yeah. Is it clear so far the story? So combining grouping with typing, the blood groups are 8 types. Okay, both these 4 categories have positives and negatives. That's it. So hence we got 8 types of blood groups: positive, A positive, A negative, B positive, C blood. Clear now? Yeah. Then last time everywhere we need to give some laws. Laws means universally accepted or standardized formats, we can say. So the law of Karl-Steiner is very interesting. That is called Karl-Steiner law. He said a very nice definition about blood grouping. He said, if a particular agglutinogen, A-G-G-U, agglutinogen present in RBC, if a particular agglutinogen present in RBC, the corresponding agglutinin must be absent in the plasma. Must be absent in the plasma. Must be absent in the plasma. That means if a particular agglutinogen, say for example antigen A, if A is present in the RBC, the corresponding antibody, what is the corresponding antibody? A antibody. The corresponding A antibody must be absent in the plasma. That's the rule. This is very simple rule. If A is present, A antibody must be absent. See how groundbreaking this law is, how simplified this law is. Now let us incorporate the law into the system. Okay? When we incorporate the law into system, A group individual must not have A antibodies. Am I correct? Hence he have B antibodies. B group individuals must not have B antibodies. Hence he have A antibodies. Then our Landsteiner law applicable here also. If particular antigen present, corresponding antibodies should not be present. Since here A and B is present, both the antibodies are absent.
Yes, sir.
See the law perfectly fit here. Then, if a particular agglutinogen is absent here, antigen is absent, now vice versa. Antibodies became present. A and B antibodies present in the plasma. Right? We already know these things. Don't look confusingly. Okay, I was reading that. Maybe what you said, Kushin? What he said, if antigen present, that corresponding antibody must be absent. Here we have both the antigens, so both the antibodies are absent here. That's why there is no antibodies in every group. That is the law, right? Antigen is there, means the corresponding antibody must be absent. Here, since we got both the antigens, both the antibodies are absent. Since there is no antigens, antibodies are present. Okay, simple. Yeah. Now, methods of grouping. Methods of grouping. Methods of grouping. There are two methods of grouping.
Reverse and forward.
Yeah. Methods of grouping, there are two types. If we are detecting antigen on the surface of RBC by using the corresponding antibodies, A antibodies. Okay? So yeah, that's it. I am using A antibodies to detect A antigen, right? Antibody-antigen reaction. Antibodies are specific to their antigens, right? Yeah. Now listen. When we are detecting the antigen in the patient sample, this method of grouping is called as forward grouping. when we are detecting antigens in the patient blood. That is called as forward grouping. Now, I don't want to check his cells. Okay. Now, in the second case, what I did is, I took patient blood, I centrifused the blood. Okay. After centrifugation, what happened? I got a supernatant plus I got a sediment. I discarded the sediment. I took only the supernatant. Serum. I took the serum. What serum will have in the patient? Serum will have antibodies. A antibodies, B antibodies, or nothing. Can I able to detect blood group by using serum? I can, right? If the patient has A antibodies, what is his blood group?
B positive.
B. Okay, B positive, negative, different. Okay. If patient has B antibodies, what is his group? A. If patient has both A, B means?
O.
Very good.
O, sir.
O. Okay. If patient don't have any antibodies, then?
AB.
AB. See, this is called as reverse grouping. This method is called as reverse grouping. Detection of antibodies in the patient rather than antigens. This is called reverse grouping. I know now Shobham asking a question. Why we are doing this reverse grouping?
No, sir. I'm asking because, sir, we are doing for the cross matching.
Yes, for cross matching. I hope you understood the concept of cross matching. If not, I will give a detailed explanation. Why? My next question is, why we are detecting antibodies in the patient? We already know the antigen. Then why we are going with this? I will give you one classical problem. Then you will understand. Okay? Listen. A classical problem.
Fetalysis reduced.
See. Yeah. There is a woman. Or simply I will say O group. I given blood to another O group. Donor, recipient. But I got agglutination. And she died. Why this happened? Even though they are same group. Even though they are same group. Some abnormal antibodies in the recipient, attack the donor cells. I don't know what are those abnormal antibodies. So before you are going for your grouping, first detect the recipient antibodies first. Is there any abnormal antibodies in the recipient targeting the donor cells? For that purpose, I must know his antibodies first. Hence, I will go with reverse grouping. The classical example will be erythroblastosis fetosis, if you know, right? Negative mother, positive fetus, first time exposure, sensitization, second pregnancy. If it is a positive fetus, mother has antibodies attacking the fetus and fetus will get a HDM, hemolytic disease of newborn. So, to know whether my pregnant woman patient has any issues with previous, fetal issues, this erythroblastosis issues. For that, I need to do, simple. For all pregnant women, we will go with cross matching. That's the answer.
Every time, sir?
Okay, for every second pregnant woman, especially.
For example, if...
now listen, we can't, sometimes there won't be clinical history. Better do cross matching every time. This is called cross matching. Okay, better before transfusions, do cross matching. Okay, then only you grow. So you go proceed for the next steps.
Sir, for a second time or for third, fourth, fifth?
After second, there is a regular occurrences will be there after second. Yeah, but there is another concept in immunology called tolerance and adaptation. That is a different thing. Okay. Sometimes immune system will be, it will tolerate. That is different story. Okay. Don't go with immunology now. Yeah, there are some exceptions. Anyway, clear, right? This concept. Since this is clear, so far I discussed grouping. Typing was done by Alexander Weiner, grouping Carl and Steiner, typing Lisa Monkey, then forward and reverse grouping, and you understood the antigens and antibodies in the body. Then third one is a concept in immunology, a concept very important. This concept is related to antigen antibody ratios. Antigen antibody ratios, very important. Why this concept is important, I will tell, especially for lab diagnosis. I will tell. Listen, and 3 antibodies has been binded to them. Okay. Now I got a visible clumping, that is called as agglutination. Agglutination. I have observed some agglutination in the cell. This test itself has some, a weak spot. I will show you the weak spot. This phenomenon is called as zone of equivalence. Zone of equivalence. We will see agglutination only when the number of antigens are equal to antibodies. Only when the number of antigens are equal to antibodies, I will see a visible agglutination. I will see a visible agglutination. Is it clear? Let me show you another approach with this test. The approach I will write. Yeah, I know. See, there are three, another concept here. This is one concept, and another concept here I am writing under this. The second one is, I have 3 antigens. But my antibodies are more. 10 antibodies, but 3 antigens. Will I get an agglutination reaction? I won't get agglutination reaction. Even though the right antibodies and right antigens present, but the ratio is different, I won't get a reaction. This concept is called as prozone phenomenon. In prozone phenomenon, the antibodies are excess. In prozone phenomenon, the antibodies are excess. And what is the problem with prozone? The problem will be, we will get a false negative results. You got my point? I will get a false negative results. What I thought, patient is actually assume this is a group, and I added A anti-sera. Okay, but what I did, I added excessive anti-sera. Rather than 1 drop, I added 2 drops of anti-sera. A anti-sera, I added 2 drops. What happened now? The antigen antibody ratio disturbed. Okay, I won't get any reaction. Since I added 2 drops of anti-sera rather than 1 drop of anti-sera, what happened? My antibodies are increased, antigens are decreased. Will I get reaction? I won't get reaction. Then what we will think? This is O group only. Even though they are A group, but we got a O group result. That means we got a false negative results. Now we understood, right, how I got a false negative results? Because of my technical error. Rather than 1 drop of anti-sera, I added 2 drops of anti-sera, leading to prozone phenomenon, leading to a false positive or negative results. Got it? Yes. Similarly, on the other end of the spectrum, the antigens will be more and antibodies will be less. This phenomenon is called as post-zone phenomenon. In this, again we won't see any reaction. Post-zone phenomenon, here also no reaction will be seen, hence we will get a false negative results. False negative results. So, now we understood, right? By understanding this concept, we understood that for 1 drop of blood, we must add 1 drop of anti-sera. When we are not adding similar proportions, we will get issues. Is it clear? Yes, sir. Now, we already know the other concepts in the testing phase. I will take a slide. What is the right approach, tell me students? Shall I keep anti-seras first, A, B, D, or shall I keep blood first? Blood first or antibodies first? Tell me students. Blood first. Okay, see, if I keep blood first, I kept 3 drops of blood. Okay, then I added my anti-seras. When I am adding anti-seras, sometimes students might touch with the blood drop. Anti-sera might touch with the blood drop due to eyesight issues. Okay, if that happens, my antibody reagent, okay, A antibodies might contaminate this. There is a chance. Okay, there is a chance of cross-contamination of antibodies due to blood first approach. That is why the right approach will be anti-sera first. First, let us add 3 anti-seras. Okay, A anti-sera, B anti-sera, D anti-sera. Then add 1 drop of blood to each. So we are avoiding the cross, overlapping of antibodies in individual cycles, drops.
कंटामिनेशन होगा कैसे सर तीनों का ड्रॉप पर अलग-अलग होता है
Yeah, listen, during mixing, the students, what they will do, sometimes, you forgot, you mix this side and psychologically you thought you were doing correctly, but you cross-contaminated.
वो इसमें भी तो हो सकता है सर नीचे वाले में
Here, yeah, but chances will be less. Since anti-sera already added, now I'm just adding blood.
Yes, sir.
Blood mixing won't happen.
Sir, but I see number of labs doing the first one procedure.
Yeah. See, actually, I came up with one textbook. The textbook stated that anti-sera first approach is good approach.
But sir, I
In the morning I sent
Yes, sir.
sir, number of technicians doing the first procedure, not second one.
Yeah, mostly we are going with first approach, but today only I saw the second approach is a standard approach compared to first. So you keep this logic in mind, okay? Anyway, why I need to cover up? Because I got this as a okay. Then second approach will be good.
Yes, sir.
Yes.
नहीं सर फर्स्ट वाली गुड रहेगी सर फिर भी
Why?
क्योंकि ड्रॉप पर हम एक ही यूज करेंगे एबीटी वाली के अंदर अलग-अलग यूज करेंगे
Oh, that's right. Class, wait. Let Christina do this. Yes, Christina.
When they do speak in their home language, we don't understand, so we are excluded from conversations. So at the end of the day, if like there's a shortcut or a technique that we all need to know, usually we don't understand what's going on, so we're excluded, we're not part of the conversation. So if possible, could they speak English or can you translate what they say if they're not?
Oh, fine. That's a good suggestion. Yeah. See, students, but anyway, let us work on one problem. What errors lead to a false negative results? Let us see what errors can lead to negative results. One thing we already understood, excessive mixture of anti-sera. Anti-sera can lead to negative results. Then second one, contamination can cause erroneous results. Contamination can cause error results. That I will take. But I was stating about the false negative results. Any more factors leading to false negative results? Our loan said one important thing. Inadequate mixing. We added 1 drop blood and 1 drop anti-sera, but I didn't mix it properly. Maybe in hurry. Okay. Usually in blood bank this happens. We need to issue packet very fast because someone is dying in the surgical room. So that time that might happen. So inadequate mixing can cause false negative results. Any more?
Improper hand.
Temperature. Okay. The room temperature affects. Okay. Listen, most of the reactions happens at the ideal temperature, room temperatures. When the room temperature is too cold or too sunny, usually this happens in PHCs, primary healthcare centers. Okay, they don't have much infrastructure, so obviously the temperature is one factor leading to false negative results. Any more? Expired reagents. Expired reagents can cause negative results. Any more?
Improper handling.
Improper handling, inadequate mixing, that is good. Any more? Quantity, very good. That is already we discussed. Quantity, okay. Quantity of blood and serum, okay. Anything that leads to false negative. Any more? You want to add? Wrong reagent will get erroneous results. Yeah. So everything is clear, right? It's Yeah, good. This is all about blood grouping, their things, everything clear, right? Next, the most important thing, let me stop this.